Let's look at arrays in Ruby. I can define an array as follows. So I'll have animals equals, and then I can put a open left brace, and I'll have an array of strings here. Alright, so that defines an array called animals of strings, and I have 3 strings in my array, bees, birds, and bears. And if I do a put s on an array, it basically lists them out, puts a line feed after each one. I can also index arrays in Ruby using the typical subscripting that we've seen in other languages. I can say animals sub 0, and it prints out the first element. Notice that array subscripts begin at 0 in Ruby. If I say animals sub 2, it gives me out the third value here, which is bears. And another interesting thing in Ruby is if I index off the end of that array, so if I say animals sub 10 here, notice that it doesn't crash or give me an index out of bounds exception or anything like that. Instead, it simply returns a nil value, indicating there is nothing at that location. I can also use negative subscripts in Ruby. So if I say animals -1, what that means is instead of accessing the array from the beginning of the array, it actually says give me the first one from the end of the array, which in this case is bears. So animals sub -2 would be the second one from the end, or birds. I can also index a subset of the array elements by using ranges. So I can say something like this. I can say animals 1.2. So 1.2 here represents a range, and it's going to give me a new array which consists of all the elements from 1 to 2, which in this case is birds and bears. So it evaluates down to an array which is actually a subset of the original array. Now, that 1.2 is actually a range. That itself is an object in Ruby, and we can test that by going like this. We could say 1.2 and then ask it for its class, and you'll see that it's actually a range. So this notation 1.2 actually resolves down or is represented as an object of type range. Now, one of the things we can't do with arrays in Ruby is we should not try to access an array before we've defined it. So with integer variables, we've seen that we can simply define anything. So I could just say my val equals 0, and the fact that I didn't reference or define val first didn't matter. But with arrays, it's a little bit different story. We cannot do something like this, for example. I cannot say a sub 0 equals 0 because a sub 0, the array, a does not yet exist. So I'm going to get an error if I try to access an array before it's defined. Now, what I could do instead is I could say something like this. I could say a equals, and then just put an open square bracket, close square bracket, and that now defines an array, a, and it's empty. There's nothing in it. So now if I try to do the assignment I did before, it works just fine. Now, if I print out a here, it's got one element. What happens if I do something like this? A sub 10 equals 12. If I do an assignment like this, what Ruby does is it actually fills out all the values in between and sets them to nil. So it basically sets the 11th location, in this case, sub 10, and everything in between, the one that was already there and the rest, is filled with nil. Another interesting thing in Ruby is that arrays do not need to be homogeneous. So I can do things like this. So I've defined an array, and I can put in the first element a string. So I've got an array, and the first 2 elements here are 2 strings, bees and honey. And I can also put other types in that exact same array. So I could say a sub 2 equals 10,000, and notice that's a fixed num, or an integer. And this is just fine. I can even put arrays in arrays. So I could do something like this. I could say a sub 3 equals, and then I can define another array here. So here I have an array with 4 elements. The first 2 are strings, the third one's integer, and the fourth one is actually another array. And that's just fine. All of these different types can be stored within one particular array. And this is quite different than what you might be used to in languages like Java. The array class also supports a number of stack operations by default. So I can actually use an array to implement a stack without having to go implement a stack data structure. So I can do something like this. So there's an array of 5 integers. And I could ask that array to push another one on. So if I say push 6, it actually adds 6 to the end of the array. And if I print the array out, you can see that indeed B has changed and it now has that element at the end. If I do a pop, it actually returns the last value in the array. And if I print my array after the pop, you'll notice that that value is actually gone. I've popped it off the end of the array. If I did another pop, once again, that value returned, or the pop returned a 5, and now the 5 is missing from my array. So I can actually use arrays, and I can push and pop onto and from the end. Now let's take a look at hashes in Ruby. You can think of a hash in Ruby as a collection where the individual elements in that collection have labels. A hash is essentially a collection of key value pairs, not unlike a hash table in Java or in any other language. So I can define a hash as follows. So here I have a hash that maps the integer values 1, 2, and 3 to 3 different string values. And I can access these values by simply using those labels. So if I say numbers 1, it returns to me the string 1. If I say numbers 3, it returns to me the string 3. Now, the keys that I'm using here don't have to be integers. They can also be what we call symbols. So I can do something like this. So I've mapped 3 different types of food to the symbols chunky, lumpy, and smooth. So these 3 symbols, chunky, lumpy, and smooth, notice how I've defined them. I've got a colon in front of an identifier. And now to dereference these, I can say things like this. I can say food, and then I can ask it for the one that maps to the symbol lumpy, and it returns back oatmeal. I can ask it for food chunky, and it returns bacon. Now these labels are symbols, as I've already mentioned. And in Ruby, a symbol is just an identifier preceded by a colon. And symbols are very useful in Ruby for naming things or ideas. And unlike strings, symbols are canonical in Ruby. So every symbol has the same value throughout that particular program when it's running. And this is different than the way objects work. So if we took a string object and we asked it for its object ID, we might get, oops, I forgot an underscore. We would get back the object ID, and notice the value of that. And if I did it again, it creates another string, and you'll see that the object ID is in fact different. If I do this with a symbol, so colon string, and ask that string for its object ID, I get that value, and if I do it again, I get the exact same value. So these symbols basically have the same value throughout the program. Hashes with symbols can be very useful in Ruby. Take, for example, the fact that Ruby does not support named parameters like we can do in other languages like Objective-C. We can actually simulate this with a hash. For example, let me write a method here in Ruby that accepts a hash. Okay, so there's my method. And, oops, I got a typo. And I can call this method without sending it any parameters, and by default it'll just have an empty hash. So if I do that, I'm expecting it to print true, so let me just go like this. And I could also do something like this and actually send it a hash. Okay. In this case, I'm going to get a different value. So let's run this. Oops. Alright, so when I run this, you could see that when I passed in the hash mapping profession to lawyer, it actually modified the behavior of this function. Our next topic is code blocks. In Ruby, you can think of a code block as a function without a name. And we can pass these code blocks as a parameter to a function or a method. For example, there's a method on fixnum called times, and I can do something like this. So the code that's in the braces following the method name there is what we call a code block. And whenever we call a method in Ruby, we can attach a code block to it. And if my code fits on one line, if the code block fits on one line, the convention in Ruby is to use the braces. If it doesn't fit on one line, then we can use do end. So I can do something like this. And it essentially accomplishes the same thing. So we're going to use the do end construct when the code block spans multiple lines, and we'll use the curly braces whenever it fits on one particular line. Code blocks can also take parameters. So I could do something like this. I could define an array of animals again. And I could say animals, and there's a method on array called each. And at the beginning of my code block, I'm going to put my parameters in vertical bars, and then I can reference that parameter in the code block itself. So in this case, each iterates through the array and calls that code block, passing it the value of that array position to the code block every time. So we basically print out the contents of that array. Now you might be wondering, how do code blocks work in the sense of how are they implemented? We've seen how we use them, and we can pass a code block to a method and it will call it multiple times. So how do code blocks work? So we've seen how to use them. You might be wondering, how do they actually get implemented, and how do they work? So one of the things we can do in Ruby to understand this, we can actually take advantage of Ruby's capability to extend or modify an existing class. So let's go ahead and add a method to the fixnum class that behaves just like the times method that already exists. So we can do that by using the class construct, and we'll talk about classes in more detail shortly. And we'll define a method here called myTimes. And we're going to implement it by saying I equals self. And self here is a reference to the object, which is the context of this method invocation. So it's very similar to the this pointer in Java. And I'll go into a loop and I'll say while I is greater than 0, and in the loop there I have a statement yield. And what yield essentially does is it calls the code block that I pass to this method. And the code block then gets executed. So I could call this method and pass a code block as follows. I could take an integer 3, for example, and I could call my times, and I could simply pass in a code block with whatever code I wanted in it. And if I run this, sure enough, it prints out the string, or it executes that code block 3 times. So the yield statement basically calls the code block from the method. And we can also pass code blocks, or pass parameters to code blocks. So let's take a look at an example that does this. So I'm just going to define a method, myFunMonkey, and it will take a parameter I, and I'll put a loop here, and I'll yield, and then I'm going to put the value I. So I'm going to pass a parameter using the yield, and then I'll loop until I is greater than 10. And now I can do something as follows. I can say myFunMonkey, and I'll pass it, say, a 1. And then for the code block, once again, I'll use the variable or the parameter I'm passing to that code block. I'll put it in vertical bars, just like we saw previously. And I can put a statement here. And so I'll basically call this code block as the method myFunMonkey iterates, and it's going to reference the I value that I'm passing it in the print statement. So let's run this. And you see that it increments. It's not exactly what I expected. Oh, I wanted a 1 here, not an I. And sure enough, it iterates from 1 to 10, calls the code block each time, passing I as a parameter. Now, so far in all of these examples, the code block has been handled anonymously, but we can also pass blocks as first-class parameters in Ruby. So, for example, I can do something like this. We'll define a function called actuallyDoIt. And this syntax, when I put ampersand block here, allows me to pass the block and give it a name. And I can call a block by calling the call method on the block. So I'll define one more function here. And so what's going to happen here is I'm going to call the method, pass it along, and I'm going to pass a block. And that block is going to actually be the parameter ampersand block here. And instead of calling it and pass along, I'm going to actually pass it to the next method, which is called actuallyDoIt. And there it does get called and executed. So if we run this, oops, you had a typo. It ultimately gets called. Now, we can use this technique, this syntax, the ampersand block name, to pass around code blocks of code among our methods. And in Ruby, this construct is very useful when we want to delay execution. We pass a block of code and we want that to execute later when some conditions are true, perhaps.